see my screen, right?
Can you
All
please
right,
zoom
let's go.
in like one times more? Yeah.
Right. So yeah, here they tell us, but this is the question 3. I don't know which year it's from, but we know that it's sequence and series, right? So question 3 says the fourth term of an arithmetic sequence is -3, right? So let's write down our information, right? So they say arithmetic, right? So T4. So Zama is also joining us. Just accept her. Right. So it says T4, right, is -3, right?
Yes.
And the 20th term is -35. So just write down what we have. T20 is equals to -35, right? And then it asks us to determine the common difference and the first term, right? So our aim, we need to find our D, right? And our A, right? Yeah, you can call it A, you can call it T1, right? So this is what we have here, right? And we have 2 sets of information. And in our formula, let's just write down our formula for an arithmetic, right? So help me. So it's Tn is equals to
N plus 1D.
A plus N minus 1D. Like this, right?
D.
Oh, sorry.
Right. And one thing that we can see here is that we have T, like as they've given us, they say T4, right? So we have N. So our N is sorted in both equations, right? But what we don't have are our A value and our D, right? So we have 2 unknowns because our N value, we can find it by substitution. When we substitute -3 here at Tn, we know that our N is going to be equals to 4, right? So therefore we have 2 unknowns, right? So we have 2 unknowns and we have 2 sets of information. So we can just integrate simultaneous equations, right?
Yeah.
Are we together, guys?
Yes.
Yes, Mr. T.
All right. So let's go ahead and replace. Let's start with 35, right? Just because we feel like it. Let's start with 35, right? So we replace here -35 is equals to A. We do not know A, right? Because it's also what we're looking for, right? Plus our N, right? They told us that 35 is the 20th term. I get. So we just replace 20 minus 1, right? Our D, we do not know, right? So I want us to do these things at the same time, right? So we can see the flow, right? And then now let's go to T4, right?
Yeah.
So they said -3, right, is equals to our A, we do not know, plus our N, though, they said -3 is the 4th term, right?
Yes.
So let's replace our N, 4 minus 1, right, into our difference, which we also do not know, right? So let me just accept Potimo. So yeah, if I come back and then it restarts, it's okay. Understand? So it's fine. Let's continue. So here what we have, let's just multiply out the bracket, right? So we still have -35 this side, right? A plus 20 minus 1 is 19, right?
Yeah.
19 multiplied by D, it's 19D, right? So yeah, if you have any queries or anything, just stop me anytime, right? So here we can, since we're gonna be looking at a simultaneous equation, right? It's quite convenient to make at least one thing subject to the formula, right? So one way, if you like, right, you can just take the A to the other side, right, and divide both sides by 19 if you want to make D subject to the formula. But since A does not have any coefficient, right, it makes it quicker for us to make it subject to the formula, right?
Yes.
So A is equal to -35. If we take this positive 19 to the other side, it's going to be -19D, right? So we have -35. We found it here, and then our -19D joins the party here, right? And then that's equals to A. So that's our equation 1, right? And now let's move to this one. So we still have -3 is equals to our A,
3D.
right? A plus 3D, exactly, right? A plus
Mm.
3D, right? And yet again, here we have A without a coefficient, right? Or our coefficient is just 1, right? So we
Yeah.
can make that also separate out the formula, right? So
Mhm.
our A is equals to what? Negative 3 minus D,
Minus 3D.
minus 3D, right? Exactly.
Mhm.
So I just want to write this properly. So it's negative 3, right? Minus 3D, right? Is equals to our A.
Yes.
Agreed. So
Agreed.
if I'm equal to 1 and you're also equal to 1, it means we are both equal to each other,
Equal.
right? So both of them are equal to A, and
Yes.
it's therefore legal for us to equate them, right? So this is going to be our equation
Yes.
2, of course. And then now we can resume, right? So we can just equate that with that because they are both equals to that, right?
Mhm.
So we have negative 35 minus 19 D, right, is
Mhm.
equals to negative 3 minus 3D.
Thapelo,
Hmm?
do you think it's necessary for you to like before equating them to write equation 1 equals to equation 2?
Right, we can do that, right? So yeah, and it makes the flow easier for at least that's what I think for our marker.
For the mark. Yeah.
Yeah, right. Yeah, we can say that.
Thank you.
Right, yeah. Let's continue, right? So
Mhm.
yeah, we just group our like terms together. So we can see that we have now one unknown, right? And if we can find this D, right, we can come back and replace our D into any one of these formulas, right? And then A will be our only unknown, right?
Yes.
So it's fine. So we can take this 3 to the other side, right? This negative 3 to the other side. So we're going to have negative 32 here, right? Because it's going to be negative
Yes.
35 plus 3. And then here we have negative 3D plus 19D, which I believe is 16D. Correct me if I'm mistaken.
16D.
That's correct.
Please, okay. Right. And we're looking for our D, right? So the only thing that's disturbing us from having D alone there is 16 that is multiplying, right? So we remove it by reciprocating, right? So we can just divide both sides by 16, right? And then our D is equals to
2.
negative 2, right?
Yes.
So here we found our D, right? So they asked us to find the common difference. So common difference, we are sorted, right? And the first term always is represented by A, right? And we can therefore come, right? And continue and say A is equals to, let's use this one just for the vibes, right? Is equals to negative 35 minus 19D, right? So let's just replace negative 35 minus 19 into negative 2. So let us punch that.
63.
Negative 35 minus 19 times negative 2 is 63. You got 63?
Yes. Yeah. No calculate.
Let's confirm, guys. Let's confirm, guys. Let's be sure about it. You got what? 63. Great.
Negative. No.
Hey, I got 3. Guys, I also got 3.
Sign.
Guys, I got 3.
We're getting 3, right?
Yes.
Yeah.
3 minus 6 is 3.
Oh yeah, I get you. Yeah. I get you. Oh, yeah. Let's push, guys. Let's not be heroes, the one. So in class we like playing with numbers and stuff like that, but let's make sure we use our calculators just to make sure. One. So we have 3 here, right? As our A. Right. So yeah, I believe our aim is achieved, right? But one thing I like about mathematics, right, is that you can always confirm and see, man, are we corresponding? Are we making sense, right? So let's try and do that. So we got our A as 3, so let's write down our sequence, right? Right? And then we said our difference, okay, 1, and then we minus 2 again, it's going to be what? Negative 1.
Negative 1,
right?
sorry.
Minus 2 again is negative 3.
Negative 3.
I just want to go, until fourth term. Can you see, guys? It makes sense because it shows us that the fourth term of an arithmetic sequence is -3. And that's what we have there, right? So we can go into the next question and say, at least having understood that what we wrote makes sense, right?
Yeah.
And then, yeah, so if that was 5 marks and we did everything correct, that, yeah, we should get 5 marks for that, right? So let us move to 3.2. If we're on par with everyone, are we together, everyone? Any questions?
We're together.
100.
All together, right?
Yes.
All right. Proper stuff. Like proper now. But okay, let's push. So looking at 3.2, right? And they say evaluate, right? So evaluate. And then they give us some sort of sigma, something like this. And then they write 20 at the top, so sum to 20, right? So we have 20. K is equals to 1, and then K and 3 to the power of K minus, okay. 3 of K minus 2, ne? And then here we have K is equals to 1. Horono just joined us, okay. So one thing, okay, let me just go and accept him. Right, so this is what we have here, right? Let me make sure of that. Right, and yeah, right. So this is it, right? And one thing, right, that we shouldn't make a misconception is that this is like the formula of the geometric, right?
Yeah.
So this is just more. I don't know if you can call it a rule or something, right? But we should replace our first value here and going on, right? In there to get our first 3 terms, right?
Yeah, to see whether it's geometric or what.
And then then therefore we can clarify if it's geometric or arithmetic, right?
Yes.
So, and to calculate the number of terms, right? So here, sigma, right? We know it as the sum, right? Or the summation of, right? And in this case, to calculate the sum, right? So in the way we've learned, right, is that to calculate the sum of something, right? And we want to find the number of terms of the sum that we're looking for, right? So we take top minus bottom, top minus bottom plus 1, right? And then we're gonna get our n, right? And then therefore, whenever we replace, we're gonna use Sn and whatnot, right? So our n is gonna be found from this formula here, right? Are we together?
Yes.
Right, we'll do it, right? So let's find the first 3 terms, right? So we have T1, T2, and T3, right? So our T1 will replace, right? So it's gonna be 3 into 1 minus 2, right? Because the reason why we're replacing with 1 first is because our K is equals to 1 there, right? Yes. And then our T2 is 3 to the power of 2 minus 2, right? And then our T3 is 3 to the power of 3 minus 2, right? So we're just replacing, right, consecutive numbers from the number that they've given us there, right? So yeah, can somebody please help us here? What term 1 is? It's
1/3.
A third, and then the next one is
1.
1.
A 1,
And
right?
then
Okay.
And then the third one is 3.
Oh, it's 3, right? So this is the power. Great power. Yeah, I get what you mean, right? So we have 3 there, right? Because it's the exponent, right? So yeah, so these are our first 3 terms, right? And therefore we can now judge if it is indeed, right, arithmetic, geometric, right? But just by the first 3 terms, right? And yeah, so here we can just look at it. Let's just look at it briefly, right? So here we have 1/3 to 1. So let's judge if it was an arithmetic, for example, right? Let's just make an example. If it was an arithmetic, to get from 1/3 to 1, we add 2/3, ne? Right? And then to get from 1 to 3, please slow down, great. Please use your calculator. All right? So to get from 1 to 3, right? We add 2, right? So we can see that this is definitely not an arithmetic, because we know that our first difference in arithmetic is constant, right? And in this case, it isn't. So now we are very, very sure, 100% sure that this is not arithmetic. But let's see, to get from 1/3 to 1, what do we multiply with?
1/3.
Ma'am?
1/3.
Wait,
Oh,
okay.
3. We multiply by 3. Sorry. We divide by 1/3. We multiply by 3.
Yeah, right. So, yeah, whenever we representing geometric, we always talk about the multiplication, right? So we never say that we divide by 1/3 to get this, right? We always talk about the multiplication, right? So we multiply by 3, right? From here
Got
to
it.
here. And then from 1 to 3, what do we multiply by?
3.
We multiply yet again by 3, right? So we can therefore
Yes.
confirm that this is geometric series, right?
Yes.
So let me just use a different color to accommodate the females in the room, right? So let's push, right? So now they want us to find, they just want us to evaluate. So evaluation, and we have a sigma, we just need to find the sum of, right? So we agreed that to find our n, right? Our n is equal to what? Our top minus bottom, right? So our top is 20, so it's 20 minus the bottom, which is 1, right? And then plus 1, right? So you would notice that whenever we have k is equals to 1, we always going to use the top number, because the positive and the negative one cancel out, right? So are we on the same page, family?
Yes.
All right. So yeah, without any further ado, so let's write the sum formula. So there's different sum formula for geometric and arithmetic. So fortunately, you don't have to know it off by heart, but you're gonna find it at the back of the formula sheet if we are presented one. But it's quite nice to know it. Come on. So we have Sn, right, is equals to the sum formula for the sum formula for the geometric, noting that our ratio is greater than 1, right? So yeah, different derivations of the same formula. So how do we go about this one?
Is the one a bracket Rn minus 1?
So yeah, which comes first between the R? Give it to me. Somebody.
Bracket Rn minus 1 over R minus 1.
To 12n minus 1, right? Over R minus 1, right? Right, yeah. So yeah. Sorry.
Our first term is 1/3a.
Right? Yes. So our a is 1/3. So let us replace, right? So the sum of 20, right? Sum of the first 20 terms is equal to our a, right, which is a third, as we've calculated here, right? 1/3, right, into r. Our r is, we haven't yet calculated, right? So let's just do it on the side here, right? So I believe we need to do it before we get to here, right? So our r, we know it as equals to T2 over T1, right? So if you're presented with term 15 and term 14, you can still find the ratio, given that it is geometric, right? So it's always a term over its previous term, right? Can be T15 over T14, right? So here we have our term 2 and our term 1, right? So it's just the same thing as 1 divided by a third. Somebody.
It's 3.
3, right? So yeah, our ratio is 3, right? So it's fine. Let's put 3 to the power of n. Our n is
20,
right? Minus 1, right? And then all over, our r is still 3, right? And then we still minus 1. So here we can just punch on our calculator. Somebody, sum of 20 or the first 20 terms is
8, 7.
87. Somebody please go to confirm.
Yeah.
Yes.
16.
4 squared. Yes.
96.
96.
100.
100. We all get that. Somebody please confirm for us.
Oh, wait. I made a mistake. Sorry.
Guys, I didn't get the same thing.
Yeah,
Yeah,
I made a
even me. I
mistake.
got 5-8 something.
Yeah,
I made a mistake.
So can we have the one that most people have? What is it?
8.
5, 8,
1 1
1, 1,
3 0
3, 0,
7 3
73,
3.3.
0.33. This is what we got.
No. 733.3. 733.3.
Yeah, 733.3.
This way, right?
Yes.
So this is what we have, right? So we all agree that we understand this approach and how this question and how we approached it.
Only one people.
Definitely.
Tabelo,
Sure.
for this answer. So there's no rounding off or whatnot. You just write it as it is.
Yeah.
Okay.
Yeah. Right. Okay. If we are all clear, then yeah, they gave us this, right? So they say the following sequence forms a convergent geometric sequence. Convergent, right? Convergent. So guys, can somebody please tell us about the properties of a convergent geometric sequence? There's some properties that it has, specifically with the ratio.
The ratio should be between -1 and 1.
Right? So negative
Yes.
greater than R, right? Right? And exactly right. So this is the property, right? Fine. Let's see what they're asking of us. They give us 3. Yeah, okay, they give us that, right? So this is the geometric sequence. I don't know why this is a geometric sequence. I don't know why they wrote sequence. But it's fine. Right? But it's fine. Come on. So we have 331, right? Determine the possible values of x. Right? Possible values of x. Right? We're going to be using this here. Can you see this, guys?
Yes.
And then let's just look at the next
find
question, right? Right? So they say if x is equal to 2, then calculate the sum to infinity, right? So in other words, right, the way I'm seeing it, in 3.3.1, one of the answers, they said possible values of x, so possibly we can get 2 answers, right? Or 3 maybe, I don't know, right? But one of them have to be x is equal to 2. Somehow. Can you see, guys? It's not coming from nowhere. Do you guys get me?
Yeah.
It's quite possible that could be the case. Sometimes they're just hinting you that you're on the right path, my brother or my sister. But it's fine. But it's fine, right? So should we find R first before we place into this filler, or should we do it all at once?
Let's find it first.
Let's find R first, right? It's fine.
Yeah.
So let's do it on this side, if you don't mind. So let's just find our R, right? So we're doing 3.3.1, right? 3.3.1, right? So our R, we know that our value of R, right, is equal to T2 over T1, right? So if you like the number 3, right? Yeah, I think we could, since we can see that this is our term 1, term 2, term 3, let's use this one because we can see that we have 1 over 3 there. There's no too much x and stuff. So we can use T3 over T2, right? So if you like the number 3, you can use T3 over T2, right? Choose my cat head, right?
Yes.
Right, and then okay, let's do the T3 over T2, right? Right, so now since we are dividing a fraction by a fraction, let's write it in. I don't know, let me just say linear form, I guess, right? So divided by, right? 1 over 3 divided by 1 over x minus 1, right?
Yes.
So we have division, so we tip and time, right? So here, 1 over 3 multiplied by x minus 1, right? And over 1, right? So we just flip this, but we also changed the sign to this, right? That's fine.
Yes.
Let's see what we have here, right? Okay. Here we're gonna have numerator multiplied by numerator. We're just gonna have x minus 1 over 3. So yeah, this is our R, right? So I hope everybody understand how we got here, right?
Yes, I do.
All right. So if no one has any questions, let us resume, right? So they're asking for us to determine the possible values of x, right? So determine the possible values of x, right? And we've been told that there's a convergence series. I mean, geometric, convergent geometric, right? We understand that our ratio, right, needs to lie in between -1 and 1, right? So let us replace it into that formula. So -1 here, lesser than r, which is lesser than +1, right? So let's replace. So we have -1. Our r, we have solved it, right? So it's x minus 1, right, over 3, right? And then here we have 1, right? But it's fine. Okay. So let's multiply. Wow. Okay. Let's multiply everything, right, by the denominator. So every time you're solving for x, right, you always want to get rid of the denominators. That's why you find the LCD and whatnot, right? So here we can see that our denominator is 3, right? So let's multiply both sides by 3 because that 3 is dividing, right? So let's multiply both sides by 3. So we're gonna have -3 here, and this 3 is gonna cancel this one, x minus 1, and then
3.
Right?
Yes.
Okay, it's fine. It's fine. Wait, let me see something. Okay, it's fine. I want to see something, right? So here, we're going to take the 1 to both sides, right? So since it's -1 here, right? We're going to just add 1 both sides, right? So it's going to be 4 here. And if you add 1, that's it's going to be -2, right? Right? So here, they say determine the possible values of x. So possible values of x here, in this case, it's -1, 0. I mean, -1, yes, 0, 1, 2, and 3, right? Because they lie between -2 and -4, right? So I think it also links with our next question. They said if x is equal to 2, right? And x is equal to 2, that lie between this range from -2 to +4, right? So they can't take us, yeah. So yeah, guys, we'll continue that in the next meeting, right? Because this meeting is about to end in a minute, like right about now, right? So let us continue the next meeting. So let me just play the recording and then we resume, right? Just join same time, same link. Let's push.